In this lesson, we're going to expand on our understanding of multi-step equations, and we're going to be working with equations where the variable is now on the left and the right. Previously, we were working on problems where the variable was only on one side. So let's take a look at this first problem we have above. And I apologize for this scribble here. I just changed the problem. I wasn't ready for the problem that I have all scribbled out. So let's go ahead and take the problem right above and let's go ahead and solve it just like we have been solving our multi-step equations. So I'm going to go ahead and I'm going to distribute my 5 to give me negative 30 minus 10k. And that's going to be equal to negative 36 minus 7k. Now, what you'll see here is it looks very similar to what we were doing before, but now we have a k on the left and a k on the right. And we also have a constant on the left and a constant on the right. Now, let me go ahead and fix this. I don't want to confuse anyone. I'm just going to get rid of this k right here and start a new k. There we go. Now, what my goal is to get the variable all by itself. So I need to move the variables to one side, and I need to move the constants to the other side. I can start with the variables, or I can start with the constants. It truly does not matter which one you begin with. Personally, I always gravitate toward moving the variable first, so I'm going to go ahead and do that now. So you can move the negative 10k to the right-hand side, or you can move the negative 7k to the left-hand side. Either one will give you the correct answer. But I'm just out of creature of habit, I always move my variables to the left-hand side because I like my final answers to have the variable on the left-hand side. So I'm going to go ahead and do that. I'm going to move negative 7k to the left-hand side. To move it, I need to do the opposite operation that you see happening. And I'm subtracting, so I'm going to add it to get rid of it. I'm also going to go ahead and I'm going to add it to the other side as well. So when I do that, just like a multi-step equation, my negative 30, well, nothing happened to that. And I'm going to take my negative 10k and add 7 to give me negative 3k. And I'm going to set that equal to negative 36. And because of my additive inverses, my negative 7's canceled out. Now I just have a two-step equation, so I can solve this just as normal. The goal was to get the k on one side, which I did. So now I'm going to go ahead and get rid of that number that is standing next to the negative 3k. So I'm going to go ahead and I'm going to add 30 to both sides. So I'm actually going to start moving my work up in this direction. So what I'm left with is negative 3k is equal to negative 6. I'm not done though. I still have to divide both sides by 3. Negative 3, I'm sorry. And my k will equal to 2. Now, it's an equation, so we always have a check step. So let's go ahead and do our check step here. I'm going to go ahead and I'm going to substitute my 2 into everywhere that I see a k. And then I'm going to go ahead and use my order of operations and simplify my equation. And they should be getting smaller and smaller as you go down on your check step. And we do get negative 50 is equal to negative 50. And because those two numbers are the same, what that means is that the number that I got for my answer, k equals 2, is exactly correct. So let's look at a more complicated problem. Let's look at one that has a lot of fractions. The good thing is we already know how to do operations with fractions, and we also know how to use our graphing calculator to do, simple arithmetic. So let's go ahead and look at this problem. You'll see that we have a variable on the left and we have a variable on the right, and we need to do some movement. So you really can do whatever you want. I'm going to do the opposite of what I did last time, and I'm going to go ahead and I'm going to move my variable from the left-hand side, and I'm going to go ahead and move it to the right-hand side, just to keep things interesting. So to move the variable, I'm going to go ahead and by the way, you can move the constants first as well. It doesn't matter. I'm going to go ahead and add 1/4 t to both sides. And notice how I organize my work, where when I'm adding something, I put it right under the variable that you're adding it to. So like my 1/4 t, I'm adding it to 1/2 t. So when I add it to that 1/2 t on that side, and I add it to the left-hand side, I'm going to be left with 3/8. And my additive inverses are going to cancel out here. And I'm going to be left with 3/4 t minus 3/4. Now, you'll see at this point, it's kind of hidden, but you got to look kind of carefully. But I just have a one-step or two-step equation. That's it. I do have fractions, which is okay. So let's go ahead and I'm going to go ahead and I'm going to get rid of my constant over here of 3/4. I'm going to add it to this side. So 3/8 plus 3/4 is going to give me 9/8. And over on the right-hand side, they're going to cancel out, and I'm going to be left with 3/4 t. Now, you just got to be really careful each step of the way when you're working with fractions. All right, I'm still trying to get my t all by itself. So remember that cool trick I showed you in the last lesson with 1- and 2-step equations? To get rid of a fraction like 3/4, I can actually go ahead and I can multiply this side by 4/3. But whatever I do to one side, I also have to do to the other side. So on the right-hand side, the 4's cancel out and the 3's cancel out. And I'm left with plain old t all by itself. But now I have to go ahead and simplify my 4/3 times 9/8. And I like to do some cross-simplifying personally. And I know that 4 goes into 4 once and 4 goes into 8 twice. And 3 goes into 3 once, and 3 goes into 9 3 times. So really, I have 1 times 3 gives me a 3, and 1 times 2 is 2. So my t in this problem is just going to equal 3/2. So it works just the same as the one above, except I just worked with fractions instead. And just like the one above, we also have a check step. So let's go ahead and do this check step. I have 3/8 minus 1/4, and I'm going to go ahead and I'm going to substitute my 3/2 in to my t variable. And I'm going to have 1/2, and then I'm going to multiply it by 3/2 again, minus 3/4. And it looks kind of hairy, but you'll notice that things are just going to start eliminating very quickly. So let's go ahead and look at the first one. 3/8. Now I have negative 1/4 times 3/2, and that's actually going to give me negative 3/8. And on the other side, I have 1/2 times 3/2, which is going to give me 3/4 when I multiply it. And notice I have minus 3/4. Oh, interesting. So I just have one side equaling 0 and the other side equaling 0. And just like before, because those two numbers are exactly the same, that means that my original t in my problem is exactly correct. And there's only one answer that will satisfy this equation. Let's look at two examples with special cases. I always like to talk about the special cases. Those are those things that they only happen on occasion, but you have to be aware of them. So let's look at the first special case. Let's go ahead and solve this multi-step equation with variables on both sides, just like normal. I'm going to go ahead and distribute my negative to give me negative x plus 5. And then, I got to distribute another negative. So negative 2 minus x. So I've got my x's on both sides. So I could start by moving the x's to one side, or I can move my constants. But I'll be honest, if I look at this problem, if I look at the left-hand side, it looks like I actually have some combining to do. I can combine my negative 4 and 5. So I'm going to go ahead and do that. Anytime you have an opportunity to condense the problem, you should do so. Okay, now I'm going to continue. I'm going to go ahead this time and I'm going to work with my constants. Or no, I'm going to work with my variables, I think. I always work with my variables, so let's go ahead and do that. I'm going to go ahead and add my x to both sides. To move it to one side. But you'll recognize here that this is kind of interesting. Negative x plus x. Well, that's additive inverses, right? And I'm left with a 1 equals negative 2. And then I have additive inverses again. So I have 1 equals -2. Didn't we have this situation before where we actually have a problem that it doesn't work? This is called a no solution problem. And again, what that means is that there is no number that will satisfy this equation, meaning there's no number that you could substitute in for this x and this x to have both sides equal to each other. So it just can't happen. So this is kind of the nice one because there's no way to check it. I mean, the only way to really check it is to go back and, you know, check through your steps and make sure you distribute your negatives properly. But otherwise, there is no check for this problem because there's no number to check. You can probably guess what this next problem is going to look like, but let's go ahead and look at it. Let's go ahead and distribute just like normal. And let's go ahead and combine anything that we can. It looks like we can combine something on the right-hand side. So let's go ahead and combine the 4 and the 20. You're probably noticing something. You're probably noticing that they're almost identical here. But let's keep going. I'm going to go ahead and I'm going to move my variable over. But it's really not going to let me because they're additive inverses of each other. But this time, it kind of looks like my check step where I have 24 is equal to 24. And remember, when you have a situation where both numbers are equal to each other, this answer is all real numbers. Now, since the answer is all real numbers, that means that every single number should work. So again, there is a check step for this one. Let's go ahead and check it with the number 0. I'm going to go ahead and I'm going to substitute a 0 in there because it makes things eliminate fairly quickly. Okay, I'm going to go ahead and keep simplifying down. And we do indeed end up with 24 equals 24, which, again, happens to be a coincidence that they are the same number. But what it tells us, since these two are the same, is that answer of all real numbers is absolutely correct. And we could also try another number. You could always try 1 or 2 or something small to just double check yourself. Okay, and that is the end of the lesson on variables on both sides.